Hi class, we are on to the last chapter, chapter 13. As of right now, I'm only going to cover 3 chapters from this section. That's really enough to get you through or introduction into calculus, and then my calculus series is coming next, right? So for this section, I want you to remember that we've actually talked about limits quite a bit already. We talk about them in the rational functions portion in chapter 3. I think it's like 3.5, 3.6 or something like that. We talk about left and right hand limits as we're approaching vertical asymptotes. We also talk about limits at infinity, so long-term limits. So we're really going to focus a little bit more at the left and right hand limits here as well as just as a general idea of a limit. So some of this might be review because we have talked about it in this video series already. Okay, so recall that if we have a function f, that the limit as x goes to some number is going to be a number, right? The limit of a function is a value. If it's not a value, then it either doesn't exist or it's positive or negative infinity, and that's generally when we're approaching an asymptote, right? Or we're looking at what happens in the long-term behavior. Okay, but as we approach a specific value, our function will approach a value as well. Okay, so what this means again is that as we approach the value c on the x-axis, right, as x gets very close to this number c, our function is going to approach a value. Okay, so we discussed what is happening to our function as we approach this number c from the left side, which is called c negative, right? The left hand limit, right? We're approaching it from the negative side of the number line. And what happens as we approach from the right side of the number line, which we denote with a c raised to a plus, right? We're coming from the positive side, right? Everything from the right is positive, coming downwards. Everything from the left is coming up from the negative side, right? So if my function in this case is a straight line, as x approaches c from the left, my function values are approaching this value L. As x approaches the value c from the right, from the positive side, my function is approaching these values and is getting closer and closer to the value L. So I'm saying, what is my function doing as my inputs are approaching a single value? Okay, so there's a couple of ways that we do this. Right now, the way that we're going to analyze this is numerical methods and looking at a graph like this, right? So the main limit, the numerical methods, is by plugging in values of x closer and closer and closer to this value of c. So for instance, like let's say this is 5, I'll start maybe at 4, and I'll start plugging in values getting closer and closer and closer to 5, as close as I can, really, right? And I'll do the same thing from the other side. I'll get smaller and smaller and smaller values as I get closer and closer to 5. Okay, so that's the numerical method. It's by looking at values from the left and looking at values from the right. Now, if these two limits agree with each other, meaning that if they approach the same value, then my limit exists, and the limit of that value is going to be a, right? So if the left-hand limit and the right-hand limit exist and they approach the same value, then the limit of my function is a or L, right? Depending on what notation we want to use. So if the limits do not approach the same value, so if as I come in from the left, I come to one value, and as I come in from the right, I come to a different value, meaning those two sides don't approach the same value, then my function does not have a limit that exists at that value of c. Okay. So let's look at this. Let's start with the function sine of absolute value of x divided by x. So I want to know what's happening near 0. Okay. So what I'm going to do is I'm going to plug in values close to 0 from the negative side, and then I'll look at values close to 0 from the positive side. So really what I'm doing is I'm looking at the limit of this function as x approaches 0. That's what we're going to do here. Okay, so I'm going to look at a value that's larger than 0, plug it in, and notice that this is what I get out. Then I'm going to come closer to 0. Instead of going to like 1/2, I'm just going to move my decimal place because that's a lot closer to 0. So if I'm at 0.1, so I'm closer, I'm still positive, but I'm moving in closer to 0 from farther away, I get 0.9983. If I add another decimal place, so I'm even smaller, so I'm even closer to 0, I get 0.999983. Okay, one more decimal point, I get a lot more nines. Okay, so it looks like I'm approaching a value of 1. This is very, very close to a value of 1, right? So as I get very close to 0, I'm getting closer and closer and closer to an output of 1. When I plug in negative 1, I get out basically the negative what I had before. Okay, if I add one decimal place, same thing, but it'll be negative. Same thing but negative, same thing but negative. So as I approach from the negative side, so I'm negative 1, and I'm moving closer and closer and closer to 0 on the negative side, my outputs are getting closer and closer and closer to negative 1. So when I'm really close to 0 on one side, I'm close to negative 1, and when I'm really close to 0 on the other side, I'm close to a positive 1. So the limit as I approach from the negative side, from the left, this side, I approach negative 1. That's the value I'm approaching. I don't put this 0.99999. I'm approaching negative 1. That's the value I'm approaching. When I approach from the positive side, I'm approaching a value of 1. The two sides don't match up with each other, which means that this limit at 0, as x goes to 0, does not exist. Okay. All right. So now let's look at another example where we have a graph. Okay. So I have a piecewise function. Everything is described in pieces. Again, we talked about piecewise functions in chapter 2 if you need a review. So for this graph I have above, let's look at what's happening to my function as I approach negative 4 from the left. So this is negative 4. As I approach from the left side, the negative side, I am approaching a value of 2. Okay. If I approach negative 4 from the positive side, so from this side, right, I'm approaching, my outputs are going towards 0. So at x equals negative 4, my limit does not exist because I'm going to two different places, right? So now let's look at what's happening to positive 2. If I approach 2 from the negative side, so this is 2, so I'm coming from this way, from the negative side, this is what my outputs are doing. It's going towards 4. Okay, and as I come from the right, from the positive side, I'm also approaching the same value, 4. The left and right side limits agree with each other. They're both going to the same value, so that means that my limit as x goes to 2 is 4 because they're approaching the same value.